All right, this is number 17 on the chapter 6 / benchmark 7 review packet. This is it says solve the initial value problem analytically using separation of variables. Put all answers in the form y equals f of x. In other words, solve for y. So separate the variables, so we have to get the x's to the right, so I'm going to multiply by dx on both sides. That'll make this dx cancel out on the left, and a dx will appear on the right then. Right there. Now, how would I get the y's to move from here over to the left side? Divide by y minus 5. So on the right side, you're going to have 3x plus 2. That quantity times dx. On the left side, I'm going to rewrite this because I think you might recognize what to do better if I rewrite this. Instead of dividing by y minus 5, let's write it as 1 over y minus 5. So now we have our x's on the right side, y's on the left. We get the variables separated. That's always your first goal in these problems. Second goal is to integrate both sides. Get the correct integral on both sides. So what's the integral of 1 over y minus 5? Natural log, and then of the absolute value of y minus 5. Absolute value needs to be put in because you can't take the natural log of a negative or 0. Absolute value assures that that quantity is positive. The derivative of y minus 5 would be 1 dy, so that would drop off. Integral over here. Notice it's to the first power. When it's to the first power, you should integrate each piece individually. So the integral of 3x would be what? What's integral of 3x? Right, 3 halves x squared. Integral of 2 would be what? 2x. And then technically you're supposed to put a plus c on both sides, but what we do is just combine them together and just end up with one constant over here on the right. So that's step 2. You integrated both sides correctly. Step 3 is to plug in your initial point that they give you. They give you that y of negative 2 equals 7. So that's saying y is equal to negative 7 when x is negative, or excuse me, y is equal to 7 when x is negative 2. So I'm going to plug 7 in here for y. I'm going to plug negative 2 in for x. And solve. So natural log of 7 minus 5 would be natural log of 2. Take off the absolute value there, because I know that 2 is positive. Here I'm going to get 4 times 3 halves is 12 halves, or 6, plus negative 4 plus c. So natural log of 2 equals 2 plus c. Subtract 2 out both sides. Natural log of 2 minus 2 equals c. It's not 2 minus 2, it's natural log of 2, and then so there's my constant. That gets plugged back in right there. So step 3 is done. There's only one step left, really. Step 1 was separate the variables. Step 2, integrate both sides. Step 3, plug in your numbers to find c. Now we're going to rewrite the expression with this expression here. This is what's called the general solution. Once I plug in c, I have a particular solution. So natural log of the absolute value of y minus 5 equals 3 halves x squared plus 2x plus c, which is natural log of 2 minus 2. Now, that's my particular solution, but the directions said they want the equation in the form y equals f of x. In other words, they want y equal a function of x. So they want your y, solve for y on the left, everything on the right should be in terms of x. That's what that's telling you in the directions. So, I need to get rid of that natural log. How can I get rid of that natural log? Right, it's called exponentiating both sides. You're going to raise both powers, put an e as a base underneath both of them. So it's e to this power equals e to this power. Then you can, the e and the natural log undo each other. So you get the absolute value of y minus 5 equals e to the 3 halves x squared times e to the 2x times e to the natural log of 2 times e to the negative 2. That's the rule from algebra. In algebra you had like e to the a, you probably didn't use e, but you used maybe a or something, but e to the a times e to the b would equal e to the a plus b. Remember that from algebra you learned to add exponents when you multiply? So we're just going backwards. If the exponents are added, we can use the base, put the base underneath each piece and make this multiplication. So that's what I did in that last step. Next, I'd like to take the absolute values off.
Mr. Harms, please call extension 303. Mr. Harms, call 303.
To take the absolute value off, what do you have to put on the right side? Plus or minus. Let me explain why one more time on that. If you have like absolute value of 10, take that back here, try that again. Absolute value of x equals 10. What two values could x equal? Plus or minus 10. Right? Positive or negative 10 would work here. So if you take off an absolute value, that means you put a plus or minus over here. That's what I just did. Next, add 5 to both sides and simplify a little bit. And we're just about done. So y equals plus or minus, we'll make the decision in a minute, e to the 3 halves x squared times e to the 2x times, what could you simplify that to equal? That's equal to 2 times e to the negative 2. But you could put that underneath and call that 2 over e squared if you wanted to.
But do you have to do that?
No, plus 5. Now you have to make the decision. This is going to be my answer with the exception I have to decide whether it should be a plus or a minus here. This graph has to go through the point negative 2, 7. So if I put negative 2 in for x, I have to be able to get 7 for y. So let's figure out whether the plus or minus would help me get 7. Oops. For x, you're putting in negative 2. So this is going to be e to the 6th right here, times e to the negative 4 times 2 e to the negative 2 plus 5. So if you combine these together, e to the 6 times e to the negative 4 times e to the negative 2, what would you get? E to the what? E to the 0, which would equal 1. So 2 times 1 would be 2. So the question is, do I want this to be positive 2 plus 5 or negative 2 plus 5? Positive 2, because you want it to come out to 7. So if you make this positive, this will come out to 7. So we don't need the minus. We want this to be a positive e to the 3 halves x squared. Questions now? Remembering the steps. Separating the variables, integrating both sides, plugging in your numbers to get c, solving for y, and then that last little step, sometimes you have to figure out whether it's going to be positive or negative.